Hello everyone! Today, we are diving into a fundamental concept in organic chemistry. What exactly is a derivative? It might sound complex, but it's actually quite straightforward once you break it down. Let's explore this important idea together. First, let's define it simply. In organic chemistry, a derivative is a compound that is derived from another compound. Think of it like a modified version of an original molecule. You start with a parent compound, and then, through a chemical reaction, you change a part of it to create a new, but related, molecule. The key idea is that the derivative still retains a significant portion of the original molecule's structure or its core identity. It's not a completely new substance, it's more like an upgrade or a slight alteration. So, why do chemists make derivatives? There are several important reasons. One major reason is for identification and characterization. Sometimes, the original compound is difficult to analyze directly. By converting it into a derivative, chemists can create a new compound that is easier to study. For example, it might have a more convenient melting point or boiling point, making it easier to purify or identify using standard laboratory techniques. 2. Another reason is for purification and isolation. Converting a compound into a derivative can help separate it from impurities. Once purified, it can often be converted back into the original compound. 3. Derivatives are also crucial in organic synthesis. They serve as intermediate steps in building more complex molecules. By temporarily changing a functional group, chemists can protect it from unwanted reactions, allowing other parts of the molecule to react selectively. After the desired reaction, the protecting group can be removed, regenerating the original functional group. 4. Furthermore, making derivatives allows chemists to modify specific properties of a molecule. For instance, you can change a molecule's solubility, its reactivity, or even its biological activity by creating a derivative. Let's look at some common examples to make this clearer. Consider carboxylic acids. These are compounds with a COOH functional group. Many compounds like esters, amides, acid chlorides, and anhydrides are considered carboxylic acid derivatives. They all have a C=O group connected to something that originated from the carboxylic acid, and they can often be interconverted. For example, you can react a carboxylic acid with an alcohol to form an ester. The ester is a derivative of the carboxylic acid. Similarly, if you start with an alcohol, you can react it to form an ether or an ester, making these derivatives of the alcohol. The change is often in one specific functional group, while the rest of the carbon skeleton remains largely intact. It's about taking a known chemical, making a small, deliberate change, and creating a new substance that keeps the essence of the original. In essence, a derivative in organic chemistry is a compound chemically derived from another, retaining the fundamental structural skeleton, but with one or more functional groups modified or added. It's a powerful tool for chemists. Thank you so much for watching and learning about derivatives in organic chemistry with me today. I hope this explanation was clear and helpful. If you found this video useful, please consider giving it a thumbs up and subscribing to support the channel. Your support helps us create more educational content like this. See you in the next video.